Hello everyone, this is Kriti Shaw, and today I'm going to give you a presentation on Yelp predicting future business attention. What you see on the screen right now is a heat map which basically shows you the number of reviews that has been received by businesses in the Phoenix area of Arizona. The red spots that you see are basically the hot spots that are the most popular areas. So, what we are going to predict is how much attention a business will receive in the next few months using the Yelp dataset. After its so many years of operation, Yelp has amassed an enormous amount of raw data on businesses. While businesses are able to see their current ratings and the raw text of their reviews, there is no information relating to forecasts about their business. Are they going to become more popular? Will their business increase? With this knowledge, a business owner can actually determine that something is wrong with their business model or that a new product they added is a really big hit. We are basically going to use 4 tables: the business table, the user table, the review table, and the tip table. We I have identified 2 categories of features here. The one specifying the metadata about the business, like the business statistics like the latitude and the longitude, the category of the business, like temporal data about the businesses like the maximum number of reviews in a day, the number of reviews that the business has received, the rating, the days since it has received the last reviews, etc. And also the number of businesses within 1 kilometer found by geographical clustering. We feel that these features would help us predict better the amount of attention the business is going to receive. Along with this, knowing something about the user base is also very important. So what we've done is we've clustered the user base using k-means clustering into a number of sections. Like we see the basic users who remain normally active in the Yelp business, the happy users give just 1 or 2 good reviews and then vanish, long timers who have been there almost for years and years of operation, etc. Other than this, what we can use is we've done geographical clustering of businesses to find out the number of businesses within 1 kilometer about a particular business. That basically gives us a popular location, and this information would be really helpful if we want to find out how a young business would do. The location would be really helpful. Other than this, we've used the review text as features. We've done analytical processing on the raw review text, basically involves removal of stop words, the punctuation, excessive extra things. We've tokenized the sentences into words and then match all these tokens into from a positive text dictionary and negative dictionary to come up with feature vectors like the positive word count, the negative word count, and numerous other features which I'll show you later, and use this as feature vectors. So these are the features, and then since we have such a huge number of features, we have to come up with logical subsets of features that would help us predict. Now there are different methods for doing that. First is we use our domain knowledge to come up with logical subsets. If we just think the number of review count is a really important feature, then the star rating about a feature or business is a really important, the location is really important. So we can come up with logical subsets ourselves. Other than that, we can use PCA for reducing the dimensionality, because it becomes really computationally infeasible for a prediction model to run if the number of features or the feature space is really huge. We can also employ methods like univariate feature selection and also random forest regressor to come up with a lot of good features. And then we can also come up with correlation between different features in terms of correlation ratio. Now what we've done is we'll be predicting the future business attention. So we've used 3 types of prediction models. One, prediction using all the original features that are present in the data set. We've used the original features as it is from the data set, and then we've put it into a prediction model. Other than that, we've used prediction using metadata about business. We've also done prediction using the review text features. Now I'll tell you how we did go about it, like training a classification model and then testing it. For our training data, we selected a particular date. We've done temporal prediction, so we've selected a particular date, say somewhere around in 2014, and then we've logged off all the data that was logged into Yelp before 2014, and then use that as our training data, and then we'll be predicting the amount of attention that the business has received based on the test data. The test data will be all the data, all the reviews that the business has received after that particular date in 2014. And we've divided the business attention, we've kept another feature vector, that is the label. We've divided into 5, like a scale of 1 to 5, the 5 being the highest, which is the amount of attention the business will receive. For temporal prediction, we've used models like SVC and random forest predictor. We'll be showing you the results now later. And after PCA and univariate feature selection, the best features were selected were the number of reviews for a business, max number of reviews logged in a particular day, number of useful, funny and cool user votes, star rating for the business, number of positive word counts for the business, number of negative word counts for the business. Other than this, here we show you the confusion matrix and the classification report for one prediction model, that is the random forest model. As you see, the prediction is quite accurate and the accuracy level is very high. These are the classification report metrics. We have the precision, we have the recall, accuracy, they are very high. This could be attributed to the fact that we've divided the business attention into just 5 levels. Had we been predicting the number of reviews or something that were more granular, the prediction level or the precision could have gone low. Here we see the misclassification error comparison, which will tell us which of our prediction model was better using the random forest model and SVM model. We see that the prediction that we've done using the metadata about the business and also the review text features give us pretty good results in comparison to the original features that were present in the data set. Here is the prediction accuracy for 4 businesses. This was quite accurate using the business metadata, the review features and the original features. It was quite accurate and the prediction level was pretty high. This was all about a presentation, and now I'll show you by running our code. We basically used the Spark notebook, here the Spark code in Spark, the Python code, and to generate a data set. So firstly what we've done is we've generated a data set here. We've imported all the modules that are required. We have set our Spark home. We are reading the JSON files here. We're reading the business JSON file, the user, the review and the tip JSON file, and then we are basically doing an inner join on the business and the review data frame and coming up with a particular data frame, and then we are doing it on user ID to come up with a data frame which contains business, user and review data, and then finally we've combined the tip data frame to come up with something that contains information about the business, review, user and the tip. This basically shows you the header of the data set that is generated. It contains all these features that we can see here. So it gives you a glimpse of the data set that we'll be working on. Here we've deleted the variables that are no longer required, which is just eating up our RAM. And then the data frame that we have generated, we are writing into a CSV so that we can do some Excel functionalities on it. So this is how we have generated a single data set. And then we come up to generating features, like feature extraction on our many feature extraction. So what we've done is we imported the required module. So we'll be using NLTK here to tokenize and then come up with different features. So we are reading the positive word file and negative word file and the stop word file. We are reading the CSV file here on which we will be providing doing our feature extraction. We've written specific functions here to basically categorize the one into cool, funny and useful, to split the data, remove stop words, get total number of review words, get number of compliments that are cool or funny, etc. Then the number of positive word count, the number of negative word count, and check also that the user, it's something with related to friends of the users also we've done. So here we basically generate these features by employing the functions on the particular data frame that we've entered, that was read previously. A number of features are generated here. If you see the number of review votes, funny, useful votes, and the review length. The review length is also very important, to find out if the reviews were fake or they were real reviews. Then the number of user votes here, the user compliments as cute, funny, hot, etc. the positive word count, the negative word count, the neutral word count, these features being a lot more important in predicting the business attention. What we've done is we've generated all the features and written into a particular CSV, and then we also found out correlation among the different features, just to come up with logical data sets, logical subsets of the features to predict the business attention. So if we see the business review count here, and we can see the correlation of it with respect to the all the features, and this was really helpful in coming up with best features to predict the business review count and the business attention. And we plotted this also, we included this in our report. Next, what we do is we'll be predicting, I'll show you, we'll run the code on the prediction model that will be predicting future attention for the business. So we'll import all the modules here. We're importing NLTK, doing some pre-processing, and then we are importing all the modules required for running the classification and the regression models. So we are reading the training and the testing data set. As described earlier, the training set contains of all the data that was logged on before a particular date in 2014, and the test set contains the data after that, so that we can predict the future attention or the attention the business has received in recent times, and then test the accuracy of our prediction model. So here we've written functions to come up with a confusion matrix, and we're using basic libraries in Python from scikit-learn, and then we come up with different classification matrices, precision, recall, which could give us a basic evaluation on how our model has performed. And then we are basically running the random forest predictor on our data, and then this ran on 644 milliseconds, which is a pretty good time. And then we come up with a class confusion matrix. Here you see the actual label and the predictor label, and the accuracy level is pretty high. As told earlier, the accuracy level is very, very high, and the precision, okay, we'll run this part. The precision level is also very high. This could be attributed to the fact because we've divided the amount of attention into just 5 metrics. Had we granularized the data more, the prediction level or the precision level could go wrong. This is a lot of potential, this particular project, as we can predict a lot many other things. We would be able to predict the number of reviews also using the same model, particular number of reviews that the business is going to receive. Then we'll employ the SVC model. We are reading the training and the test set. It took 1.12 milliseconds for running that, and then we'll come up with a plot. SVC model, here also you see actual level and the predicted level. The accuracy level is a bit lower because we have not scaled our data, which is required in the SVC model. And then we come up with classification matrix. The precision is 0.5, the recall is 0.7. As I told you earlier, it's a bit lower than the random forest model. We've also ran another code to come up with the misclassification error for the random forest and the SVM model. As you see, the random forest model performs quite better than the SVM models. So this is all about a code structure. We can also show you how we've done our clustering. This is our user clustering code. We can run this in R, and we'll come up with the user clusters here. So it's reading the data and it's running. So we'll come up with this plot which shows the user clusters here. I've shown this. Let me just increase the size. So these are the user cluster. I've shown this plot in our particular report. Then I've also done geographical clustering of the data to find out the number of businesses that are within 1 kilometer of the code. Let us see the plot for that. We run the code, let it run. It will take a while. So this is basically the geographical clustering that we've come up with. So we can see the number of clusters with respect to location. So this is all about a code structure. Our prediction results were very high, and as a conclusion, what I would like to say is this particular project was really challenging, and I enjoyed doing it a lot, and I would like to use all these code and the prediction models for predicting a lot many other things. Thank you.